Hi all, I'm Vijay Jethani. So in today's session, we are going to cover automated operations. This is session 1 of masterclass series on automated operations. So first let us look at what we have agenda for today. So first of all, we will cover why automated operations. Then we will look into what exactly are GITOPS, DATAOPS, MLOPS and DevOps, which are nothing but a form of automated operations. So in this, we will cover basically the workflow of each of them, how they relate to each other from an automated operation per se. Third important thing is to think about what is the multi-cloud strategy, because the tools which we select for automated operations, they should be able to work on any cloud. It may be public, private, or even hybrid. So that is where we have to decide on multi-cloud strategy. And then security operations as a practice for all of whatever we are doing in GitOps, DataOps, MLOps, and DevOps, so that security is taken care of right from beginning. So that covers the first portion of this session, which is getting started. Then we will deep dive into each of the life cycle of GitOps, DataOps, MLOps, and DevOps. And finally, in the third section, we will look into what are the tools which we are going to use from a multi-cloud per se under GitOps, DataOps, MLOps, and DevOps. Now we also have to compare them based upon how they fit into the overall automated operations and how also they fit into from a multi-cloud per se. Which are the best tools we have out there which you can leverage out of box without thinking about whether you are working on private cloud, public cloud, or hybrid cloud. So that's a brief agenda which we are going to cover in this session 1 of masterclass series. So let's get started. First of all, let's think about why we need automated operations at first place. As we are talking about automated operation, first thing which comes to our mind is whether I will be able to deploy or even able to configure the things in such a way where I can able to deploy them in same and consistent fashion. That means if I am developing anything from a configuration per se or infrastructure as a code, that automation should be deployed in a consistent way is what I'm looking at from an automation operation per se. So that is the first thing why I need an automated operation. Second thing is, as I'm automating these and I have already done my checks and balances of what the problems were. So in this case, the failure rates or the deployment getting failed will be less because I have already removed, or even I would say corrected, those errors which were causing the failures. So that is where if I go with an automated operations, I have a low failure rate. And as I'm constantly automating things and obviously trying to deploy in at a level where it at every times it deploys completely without any errors, I can now auto scale based on demand. That means I can put my production environment in an autopilot mode so that based on the demand, I can actually deploy the respective services as well as configure them based on the demand. So that is what the auto scale in demand means. Then coming to the fourth, which is the version control. So here basically, as we are doing a version control, each and every template, or you can say infrastructure as a code, or even your coding files, each and everything from an automation operation per se are now managed in a version control form. That means I can now have a history of what was changed before and what it is now. And I can obviously restore them back if required. So that is where changes are now version control. So with that, I also get a faster time to recover. So what that means is if I have any disaster kind of situation or if any services fails, as I already have an automated operations in place, I can recover faster because I have an automated workflow in place to recover from this failure. Let it be the service failure, infra failure, or you can say a code changes which might be causing the problem. It can be any of those. So overall, from the consistent deployments, lower failure rate, auto scale on demand, version control, and faster time to recovery, I'm actually increasing my operational efficiency. So this is the main goal of why we need to go for automated operations. So I will have a pause here for a while so that you can look through this. Okay, so this is the first part of getting started on automated operations. First of all, we need to understand why we are doing this. So that is the reason this particular flow, or I would say specific pointers on why we need automated operations is important to know. Now let us understand while I go for an automated operations, what are the things I have to look or what are the basic component of automated operations. So here let's start with the bottom. That means irrespective of whether I'm doing DevOps, I'm doing a DATAOPS, MLOPS, GITOPS, all are related or having then automated operations in place. So obviously I can cover all four of them as a part of my automated operations. Now what each one of these does. This is for someone who is starting fresh. So for the beginners, I'm just explaining what exactly that is. Say you're starting fresh on DevOps. So DevOps basically automates your development and deployment processes to increase operational efficiency of the way you develop your product or the way you release your product, and finally deployment of that in the production. So that is the in short description of DevOps. Say you are starting fresh on DataOps. So what that does is it is basically data warehousing, or I would say creating an analytics engine on top of the data which you may be getting from different varied sources and trying to have some kind of reporting and dashboard from that. So that is called DataOps. MLOps, it's nothing but your machine learning workflows and deployments which you are trying to automate to create a maintainable ML models. Now this machine learning models are the experiments which normally a data scientist does, and based on the use case and the parameters you actually want to train those models so that you get a consistent result from that, whether you failed or pass with the help of that machine learning model. So that is MLOps. GitOps is more towards how you set up your infrastructure or platform automatically. So that is the provisioning and configuration in sync with the desired state. Now, when I say desired state, it is nothing but I have already have a templates or some configurations which I want to have in production. And if something is changing, then I need to take care of that in a form of a drift or apply the automated changes to keep the configurations and the services in place for the production environment. So that is the GitOps. Now let us look at this flow. Now, irrespective of whether I'm using the DevOps, DataOps, MLOps, or GitOps, I need at first place a version control engine, which we call as a source control management. Now, this version control engine or repository will help me keep the templates, the code, whatever I have in the form of the files, which can be version control in a source control system. Now here we are mainly taking Git as a source control system. So we will only talk about Git in this particular session. Now, as I've selected the source control, I also need to have an IDE. That means before I actually have my source control management system, I also need to have a way to build that code. Or even if I'm working with GitOps, I need some kind of text editor where actually I can have some kind of templates, like say suppose example Terraform templates. Similarly, any kind of the resource manager templates. You may have any cloud formation templates. So there can be n number of varied templates, but for that I need some editor. So that is where we have written, we basically need a source control management plus an ID at bare minimum, irrespective of where I start for this automated operations, whether this is DevOps, DataOps, MLOps, or GitOps. So that is the first thing. Now this is the decision I've taken. Next thing is, what about the workflows? Now automated tools are nothing but they are the workflow engines which help me automate the processes for DevOps, DataOps, MLOps, and GitOps. So I would select the tools which are best fit for a respective those workflows. And those workflows, once I select those tools, and here we need to take care of that these tools, automation tools, will basically take care of everything you think from a code build per se, the code deployment per se, the releases, or any form of the packaging of the product, you can say, from an automation per se. So this is what the automation tools will give me as an end result. You can say CI/CD as a continuous term, but depending upon whether you are using GitOps, where CD make more sense than CI. So there, that is where you have to be using different workflows based upon whether you are using it for DevOps, you are using it for DataOps, you are using it for MLOps, or using it for GitOps. So I need to select tools which are capable of doing end-to-end CI or CD and CI/CD both as well. Now these tools we will discuss in a short time. At this point of time, just understand from the workflow, I will need some kind of tool which will automate my workflows. Now, once I have those tools, I need to segregate, as I said, whether you need a CI or you need a CD or you need CI plus CD both in form of a build, release, and deployment pipelines. So wherever you go, these tools will use the terminology of pipelines workflows, where you will actually create the workflows, have integration with the respective source systems, from where they will fetch your code or the templates and then deploy them to a respective platform services. And at the top, obviously, as I said, this has to be a multi-cloud. So whether you are going on Azure, Red Hat, AWS, Google, OpenShift, or any of the private and hybrid, it should work across the multi-cloud. So that is the main aim of having an automated operations. So this is the workflow you have can remember. Irrespective of what you are using, you need to select a source control management system. You need to select an automation tool based on the requirements and configure those workflows in form of build, release, and deployments. And finally do the final deployment based on the platform you have intended to use for. So this is the bare minimum basic of the automated ops for DevOps, DataOps, MLOps, and GitOps. So I will just pause here for a while so that you can have look over this, and then we will move further. Okay, so let's move further. Now, as I said, main aim of this masterclass session is also to provide you a cloud strategy. Now, as you already seen that you are using a version control, you are selecting an automation tools and creating some kind of pipeline. So the strategy should be you need to select a source control tool which is accepted across the clouds. Let it be the hybrid, public or private, and it should provide you the appropriate version controls, maintaining the history so that you can revert back the previous versions. Also, whatever changes you are taking care, they should be actually reviewed and approved before they can be promoted to the production. So that is where the cloud strategy plays a vital role. You need to have a right source control management system or repository engine which helps you not only retain the code, have a version control, but on top of that provides you the way to review that code and promote that to production, or even maintain the drift in case of GitOps, or similarly whatever the different templates you are using. Okay, so that is the first thing which we need to have from a multi-cloud strategy per se. Now, the tool which you select from multi-cloud also should be able to cover each one of, whether you are using it for DevOps, DataOps, MLOps or GitOps. The reason that is basically everything comes for a cost, and we have to use the tools which provides us the maximum benefit without changing much of our infrastructure for deployment. Hence, it is recommended that whatever tool you select for automated operations, they are able to meet all your requirements from a multi-cloud strategy per se. Also, the whatever the applications you are deploying on ground. Okay, hence that is the also a cloud strategy. And as we have seen from the past as well, these code quality checks not only just checks the your respective code files, but it also checks for the qualities based on whether it has any uh, errors in terms of programming, or you are missing anything in the loop or functions, or even from a security per se, if you have left anything from the secrets behind. So those all things are taken care with the help of static and dynamic code analysis. Now we will deep dive into the actual implementations in our coming sessions. There you will really see this in a running, as a running example. What we are talking now, I think you can actually examine them during while you actually implement them on your own. But at this point of time, think about this as whatever the strategy you have, it should be all cloud should be supported. It should have appropriate version control. It should have an approval mechanism, a project management kind of environment where you are able to track each and everything. You need to also have a security checks, like for quality, even for you or any particular login IDs or any particular secrets are left behind. It should be able to check that. And finally, obviously, as you are working with a multi-cloud, then obviously there may be different identity and access management mechanism. So make sure you are using or aligning to something which is commonly used across the multi-cloud, so that you don't have to do different workflow for different respective clouds. You can reuse most of your codes as it is with just the creation of respective pipelines for those particular clouds. So that is what I would say in short. Okay, so once we see those pipelines in the action, I think you will realize that how difficult and how easy that can be, depending upon your security mechanism which you are selecting at this point of time, along with your DevOps tools. Okay, now coming to security as a practice. Now this is the flow which you will have from the DevSecOps per se, or any of the I would say the automated operations where you use infrastructure as a code or anything as a files to actually check right from the project start to the actual release of that particular product or feature set for that particular product. So I would start with the project inspection. So this is nothing but inception. There's nothing but before like as our project starts, you need to have a strategy in mind, how your resources will be and what is the timelines around that particular project and what kind of the configurations, a branching strategy you will have to retain your code into that particular source control system. And obviously the security policies make sense because here we have to give the developers only access to their branches and the reviewers access to the review of the code plus merging of that into the production branches. So that is where you see the merge strategy here along with the code and test. So finally you do the code review, and along with the code review you need to have not only the quality checks, you need to have if someone has not left behind any particular secrets or even the connection strings along with the dependency review. So this is the basic static code analysis which we were talking in this the previous thing, which you need to take care of while you actually commit your code on the repository. So once you are done with that, and then you actually create a package, or I would say the artifact which can be deployed. So that is where your CD process starts. That means now that package is ready for release. And once it is ready for release, that means at first, if I would have to deploy, I would obviously have the deployment in the development environment where I do all kind of UAT testing on that, whether everything is working from a user accessibility per se, even whatever was intended as the outcome, whether they're meeting that goals. And if not, then obviously go back and start it again from where it is showing the problems. So that cycles continues, but from a security per se, ideally, we are not leaving anything behind. We are giving a right access, similarly having a right mechanism in place for code scanning, secret and everything, so that irrespective of our development cycle, security is not left behind, and we are taking security or considering security at every point of time. Okay, so just a brief description on that it starts from where the project starts, before even that project starts, and you have a right management as well as the branching strategy at the start of project, because that involves who will access and who will actually promote your code. Similarly, you also have some kind of quality and security checks, and finally you do the integration testing so that end-to-end product looks as per the desire. Okay, so this all will have security as your SECOPS as your practice. So I will just pause here for a while before we can move further. Okay, so now let's deep dive into each of the automated operations. That is GITOPS, then DATAOPS, MLOPS, and finally the DevOps. So while dealing with these life cycles, we will actually start with the basic of how or what is required as a to build that as a workflow. Okay, so let's start with that step by step. Now this is the GitOps life cycle. So as it suggests GitOps, that means I have something stored in a source control system as a repository, which is Git, and ops is nothing but what is an operational automation I'm doing on top of that with the help of the GitOps tool. Now let's start with first of all, irrespective of here, everything is in GitOps, everything is infra as a code. That means all my platform related configurations may be in some form of JSONs or YAML files. Similarly, if you are using Terraform templates, then TF. So it can be any particular file which is in a declarative way you are actually asking in form of a configuration as a code or infrastructure as a code. Okay, so you can consider these two as the base bare minimum, irrespective of whether I'm using the GitOps tools or not. I have these as a form of a scripts. So in short, you consider the templates as the scripts in a the way we used to work in our traditional way of a deployments. Okay, so these templates will be kind of a scripts for me. Now to manage these templates in a long run, I need some version control. That means if I do any changes, I increase the version of that particular template file so that I'm able to know what changes I did. I'm able to retain the history. So that is where I keep them in a Git source control. Okay, so it again, this Git source control is nothing but your GitHub or any of the repository which uses Git as the source control system. Okay, so that is what is the Git source system. Now again, coming to the what we talked some time back. Now here, as a part of GitOps, our main aim is to actually operationalize or automate the deployment of the platform. As this is a deployment of the platform, so more whatever we are going to do here is a part of CD. That means the delivery of infrastructure as a code for setting the platform up. It can be your servers, it can be your microservices, it can be your databases. Everything is now in a form of a template. You have a Git source control which contains your templates, and with the help of the Git tool, GitOps tools, you are actually automating the platform implementation or services to be provisioned on a multiple, or I would say on the different clouds. It can be public clouds like AWS, Azure, and Google. It can be your own private cloud or data centers, or it can be a mix of both depending upon how you're configuring these tools. So in short, this is nothing but a life cycle of how the GitOps works. And if anything changes on your platform or the clouds, it has to be sent back as a drift deployment and configuration drift as a template, or in some kind of, you can say this is some kind of monitoring. If something is not working, service is down, or according to whatever your configurations, the cluster should have 5 servers but you are seeing the 4 servers, so that is the drift. That means you are seeing 1 server less than what is required. So that needs to be feedback and stored somewhere in form of a configuration, so that you can actually incrementally automate or create 1 server at runtime and bring it back to the 5 servers. Or in simple sense, even if one of your services is down, you should be able to bring that service up. In case of microservices, you should have a equal whatever your configurations were, you should have that replica sets in place. Even though your Kubernetes or the will take care of that from a replica per se, but then from a platform at particular point of time, you can have a snapshot of what is running in what shape with the help of the drift parameter. So that all changes you can get with the help of these GitOps tools. They actually not only monitor you for the not only deploys and provision your platform, but also provides you this monitoring so that you can always access whether there is any drift or whether there is any inefficient services, or any particular cluster is not running or something of that sort, so that you can correct them with the help of the GitOps tools. Okay, so again, I will pause here for a while and so that you can go through this particular workflow, as well as I'm just scrolling it up so that you can see the bullet points as well. So I will just read out for you in short. We need to automate the infrastructure provisioning and configurations. We are trying to use the reusable templates, which may be in some shape and form, JSON, YAML, and Terraform.tf, or in any of those files. I think you can consider a source control management system, which should have a version control in some shape and form. So that we are similarly, you have to have a GitOps tool, which will be working as a workflow engine, which will automate the deployments. And we are considering multi-cloud. Make sure this I'm stressing more because the aim of this session is for a multi-cloud automated operations, and we have to select the best of the tools which can provide us the automated operations. Then only we will be able to succeed, not only in terms of cost saving but also keeping our the management overhead to a minimum. Okay, finally, ensure infrastructure and configuration drift is monitored and recorded. So this is the first life cycle, which is GitOps life cycle, which we just covered. Okay, now let us see the next life cycle, which is DATAOPS. Now in DATAOPS, I think everything, as you clearly see in this life cycle, that data can be unstructured. Now unstructured is any form of your video files, the text files. Semi-structured can be something of Excel or even CSV, some form of a semi-structured data, key value pairs you can consider. Structured data is more of your transactional data where you have fixed rows and columns and the data is filled into those particular. So ideally, the data ops deals with the industrial equipments which may be emitting some in the data in some shape and form. It can be any medical devices. It can be any live systems which are emitting the data, and we need to capture those data. So before we can capture the data, we need to ingest the data. That means we have a data ingestion cycle. That means I need to have some connector to connect to them. That is where you see this block as a data ingestion. Irrespective of whichever the shape data form I have to first of all have a data ingestion because I have to connect to you. Then once I have the connection, then obviously I need to capture in some shape and form. Now this can be a real time versus your a batch processing, depending upon what the use case you are working on. In case of the industry which is running 24/7, you need to monitor equipments. There you will need a real time data that which equipments are on and off. So that I think you can monitor with the real time. Similarly, if something which you need to check for, say suppose patients, you have a medical parameters, and with the help of the medical parameters, you are trying to see what is the clinical health of that particular patient. So that can have a batch processing as your engine. So depending upon what your use case is, you are actually trying to ingest the data and trying to capture in some shape and form so that you can transform them in a way that is presentable, or I would say in a simple sense, I'm creating some kind of a structure in a form which can be kept in a data warehouse and finally present in form of a reports or the dashboards. So this is an overall life cycle of how actual real life example, how they get the data. Here I'm not bringing the specific products because main purpose of this session is to give you the in-depth knowledge of what exactly we do in these stages, and then in follow-up sessions when we actually implement them, you understand and correlate them with actual products, whether that product comes from any particular cloud provider or it is from any particular ISP vendor, I think that we will talk about that later. But at this point of time, the life cycle remains same irrespective of the platform or irrespective of the product which we are bringing in. So that you need to understand the bare minimum basic of the life cycle of data ops which we are trying to automate. Okay, so I'll just read out here before I pause. Data source can produce data in any form. I think you have just seen this. Data ingestion technique depend whether you're processing. This also I think we talked about. You need to capture this depends upon and how you are actually working on that data. And transformation is or cleansing varies by destination requirements. Now based upon whether you are creating a report or whether you are presenting in a dashboard, the format may be different, or whether you are even feeding them to even a function or even the application, the data form in which you are providing the output will vary. So these all things we need to take care of in an automated way, because while you are running any industrial shop floor or whether you are doing any clinical diagnostics at the hospitals, you need this in an automated fashion. That means while I plug to the source, I should get some information which makes sense to me. So in short, what we are trying to say here is we are doing a data processing with the help of data ops as a workflow engine, in short. Okay, again will pause here for a while before we move further. Okay, so let's start with our third life cycle, which is MLOps. Now MLOps is a bit different than others because in the data or even GitOps, we were actually dealing with some kind of the connecting to the system. But here it is, I think in MLOps, it is more of the how you are trying to create a machine learning model. Now that starts with actually the data scientist, which will have some kind of a complex calculation you can think of based upon the use case. That means, say, suppose we will take an example of again the diagnostics, right? A clinical based on the medical parameters, we are trying to diagnose what is the health of the patient. Okay, now to detect whether based on the parameters, first of all we need to understand what kind of the parameters we have to input. Similarly, we need to have some formulas in place which in the form of a model which actually based on those parameters provides us the correlation and also provide us the useful information to what exactly the health critical versus the condition of that patient is. So these models needs to train first of all before automating. This has to be the I would say kind of a data scientist stuff needs to be done, which is kind of creating a model at first place. And once we have a model, we need to feed this data continuously. So that means we need to train the model. So first block which you see, you need to train the model with the help of the reference parameters and the whatever the computational engine the data scientist has developed, you have to use that as a program on. Okay, so once that is trained and you see that now you are actually getting the required output from that model, then you need to package that, because here we are what we are doing is we are trying to automate so that we can deploy it in the many places. Okay, that is the reason we are packaging that model. And once that model is packaged, again we have to validate that so that it after packaging also it is providing the same desired results. Hence we need to have validate the model against whether this will run or deploy correctly on the uh, respective engines or platforms, you can say. If it is a clinical, I think it should work in hospitals wherever it needs to be deployed for that particular model or the medical equipments. So that is where you need to validate those models And finally, once they are validated, I think we are sure that this will work on a respective platform. So that is where we will going to deploy the model. And why monitor model? Because at times the based on the climatic conditions or even the geographical variations or even the different again sticking back to our clinical example, the diagnostics. So we have the medical parameters which keep on varying based upon whether it is a pandemic versus the normal the investigations which we are doing for that particular patients. So those all things need to be considered, and it will require all kind of retraining the model. That is where you need to have feed in the retraining. That means I'm just changing few of the parameters, even some workflow adjustments, so that I'm training the model in such a fashion that it provides a desired result. And if you see, if you do this manually, it will take a lot of time. And while we do this automatically, because this has to be replicated across the hospitals for the same kind of the treatment or the diagnostic which we are doing for this particular medical treatment. Okay, so that is where I think we are automating these MLOps. Uh, Now this example was just for the patient, right? So like healthcare, it can be for any of your the machines, right? The industrial equipment's not working, or maybe it is having failures at the respective intervals. You can even take that example in this and try to train the model in such a way that after a respects the few parameters go down, or maybe they are not sensors are not performing well, we are expecting that machine to fail within a 1 month or 2 months down the line. So those all things can be actually created as a model which can provide us the inputs with this kind of the models which we are trying to build. But while trying to do this manually, it takes a lot of time and also efforts. So that is where these ML ops also automating that becomes a must. So again, sharing some bullet points, and I will pause here for a while before we move further. So I'll just read out for you before we pause. Models are created by data scientists based on the scenarios and the input data, and training and scoring pipelines. So obviously you need to train it, and then obviously you need to validate, right? So that is where the scoring and the things come into picture, that really you are able to make sure that whatever you designed for it's working well. And all the infrastructure configurations and versioning of the data, similarly reusing of this, as I said, redeployment across the hospitals. Similarly, over the time, there may be another parameters being added. Maybe the pandemic has come in, or maybe something, some new machines have come in from the industrial flow. You need to take adjust yourself to such a way that this becomes an incremental than actually throw away use and throw kind of thing. Okay, so make sure whatever you are building, it works for a respective use case, and provide the valid results is the main aim of the this particular MLOps engine. Okay, I will pause here for a while. Okay, so now come to the last life cycle, which is DevOps. I think we most of us may be aware of this, but I will just reiterate because this is the bread and butter for what we do till date. So it starts from the planning stage. This is nothing but your project inspection, or I would say the project start, where you actually plan what is an expected based on the business requirements. Similarly, you plan the time frame, you plan the resources. So this is all part of your planning. Coming to the code, this is where you how you will keep your code, what will be your branching strategy, how you are going to review your code. This all will come in this particular cycle. And then once you are through with this, that means I'm done with reviewing the code. I need to build the code to build the artifacts. So this is the next cycle, which is build. The next phase, I would say, next phase of build, which will actually create the deployable artifacts, which I can then test with the help of CI pipeline, which is nothing but the continuous integration pipeline. So till here, I think we are through plan, code, build, and test. Now we are still in the dev stage because we are still working with the code. We are still not done anything with deployment. So we are here. Okay. The moment I go release, that is the starting point for actual the deployment. That means now once I do the release, that means my code is now done and dusted for the quality checks, security test, and I am now ready to release it to the for the deployment on the environments. Now this environment to start with can be a development or the UAT environment where I would do this testing to make sure this whatever the code package or it's working as expected, or before even I release it further to the production. Okay, so the release will keep that code or package ready for me for deployment with the help of the deploy stage. The deploy stage is actually where the deployment happens on any particular environment. And then once you deploy it, obviously that will be running 24/7. There will be an incremental updates coming your way, so you need to operate it is the next cycle. So it can be incremental code changes versus something changes on the feature sets that will come in your operate phase. And finally, I have to make sure that at the end of the day, whatever we are doing, it follows a life cycle. Hence, we monitor it and send back to the plan state so that any new feature sets added in a future, or if any, I would say even the any particular fixes needs to be applied, they will be monitored and fetching back to the plan state so that appropriate a ticket or release request, or I would say a build request or bug fix request needs to be created from a project management per se, and this life cycle continues. So this is the DevOps life cycle. I think again for this also I have just written some bulleted points to just explain you in short, but this is pretty much I think we all may be aware of. So I will pause here for a while so that you can go through this life cycle as well. And team, remember, as this is the masterclass session 1, we are covering bare minimum basics so that the next session when you actually try to do the hands-on deployment, we are not stuck with the basics what we are covering now. And remember, we are purposely not covering the tools because aim of this masterclass is for you to learn automated operations without any dependence on any particular vendor. It can be public cloud versus an ISV. We need to first of all make sure we understand what we are trying to do, and then slowly pick up the tools which will work on any clouds. Okay, so that is the bare minimum we want to do as a part of this session 1. Okay, I will just walk you through again, giving you some snips of what we covered so far. GitOps lifecycle. Then we covered DATAOPS lifecycle. Then we covered MLOPS lifecycle. So important thing to know here is you are actually learning the purpose of doing this now, along with what you need to build this particular operations, and then we will automate that operations with the help of the tools. Okay, so that is what is required from this particular session. Now let us try to put this in a structured form. Now whatever workflows we have talked so far, they will use some kind of the tools. Now, first tool which you have clearly seen is your source control management tools. So here we are using Git based source control management tools. Hence you see GitHub, Azure DevOps, GitLab, Bitbucket, and then a respective cloud based source repository, which is for Google as well as AWS. Now, why I said this is respective, because these cloud repositories are they only work on the respective cloud. That means AWS code repository is good for the AWS related deployment. Similarly is for your Google Cloud source. While the other, if you see, the GitHub has the complete coverage for the source control across the cloud. Similarly is for your Azure DevOps, can be integrated with any cloud. Similarly is for your GitLab and the Bitbucket. So these particular source control tools which I'm listed here are the widely used, the best practices you can say across the industry, where you can deploy on-premise versus public clouds, hybrid, and do n number of stuff. I would say all the right from your GitOps till your CI/CD and everything, from the DevOps, DATAOPS, and MLOPS, everything they can do with the help of these multi-cloud tools. So as of now, as I said, in this particular session, we are discussing what makes sense from a multi-cloud, considering that we have to do an automated operations across DevOps, DataOps, MLOps, as well as your GitOps. Okay, so from a source control management, I think these are bare minimum tools. There may be many, to be frank. I have just chose which were the best which I could find from an industry. Okay, so this is from a source control. So I've just bucketed them what they are used for. So this is for source control management related tools. Now, if you also consider the even the other parameters, or I would say grouping them in a different CI/CD, you will find that the GitHub, Azure DevOps, GitLabs, Jenkins, and Bamboo. So this is again, you would see these 4 players: GitHub, then you have an Azure DevOps mainly, then you have Atlassian products, and you will find Jenkins. So these are the main 4 product suites which you will find being used across the industry. So for CI tools, I think GitHub Actions will give you the workflows which will work for your build as well as testing, doing the static versus dynamic code analysis testing. Similarly is for your Azure DevOps pipeline. You can actually have the build pipeline versus the release pipelines. GitLab also provides you the similar infrastructure. And remember, these are publicly available, and they have the platform. Well, this is not something you have to set up. The GitHub, the Azure, the GitLab, the Bitbucket, these are kind of the automation tools where they have already the platform is set up for you. You don't need to do anything from scratch. There are few like Jenkins, you need to set up some VM, and then because they are open source, they are not available in the form of the enterprise versions. That is where they may be available, but I think the most of the industry uses them as a free or open source versions. That is where you need to, for Jenkins especially, you need to create or have a VMs available for those CI/CDs before you can actually run them for deployments or even building the code. Okay, so important, they are available as a platform to you. They integrate with your on-premise. They integrate with your any public cloud providers. So this is the best. Instead of learning whole lot of things, I think if you concentrate on few of these tools and you accordingly work on the DevOps, MLOps, DataOps, and the GitOps, that will make your life very easy from the automated operation per se. Also, leveraging the minimum tools provides you the more efficiency, provided that covers end to end of what your requirements are, or I would say what are the business requirements. So if you are able to cover this as a whole, then I think you are done with the understanding what tools make sense from an multi-cloud per se. What is the strategy which you need to have? Similarly, what is the selection of the tool which you are doing at this point of time? Okay, so coming back, I think we talked about the source control tools, source control management tools, mainly from the Git, which are based on the Git as an open source platform. GitHub, Azure DevOps, GitLab, Bitbucket, and the others, Google Cloud and the AWS code repository, which are internal to the respective cloud providers. Okay, so continuous integration, I think you have those pipelines are nothing but they actually have those workflow engines where you connect to the respective git source control systems, build the code, and have some kind of a step-by-step approach. If this fails, then whether you should continue to the next step or you should wait for that. You have to carry these steps in sequence versus parallel. So these workflows will have all this kind of a logic when you do this continuous integration. Similarly, if anything changes on your Git as a repository, it will trigger this automatically so that you don't need to do any manual stuff. So that is also the continuous integration you have here. That is the reason you are calling it a continuous integration tool. So make sure you understand which are the best tools available out of the market and use them. While we do in our next session, I think we will explain. I will show you a deep dive on these 5 to 6 major providers, and we will do this implementation on multi clouds so that you understand this end to end, and you will be able to make out also the difference, which is the best. Which also there is no, I would say, comparison between GitHub, Azure, GitLab, and Bitbucket. It purely depends upon the competency you have in your own organization, then choosing the number one versus number two versus number three. So make sure we are not in a race here. Our main aim is the tool which provides us the complete capability for multi-cloud. It provides us the cost benefit and it meets our end-to-end business requirement. So these are the 2 to 3 things you should remember while selecting these tools. Okay, now integration tools similar to that, I think the delivery tools also remain same. Mainly from a pipelining per se. Okay, so remember I have purposely given you the less options which are being adopted across so that there is no plethora of services you have to try for. You only need to concentrate on these 5 products as such. Okay, so CI was for main build and the test. CD is main from releasing for each environment and having the appropriate checks in place before that can be deployed, and then feeding back if something goes wrong back from a monitoring per se. Okay, so this is what you will have from the delivery tools. Okay, now coming to the important from GITOPS per se. Now, how this is different from the CD? Ideally, these pipelines will consume them. Okay, so ideally these are the products. You can say Argo, Flux, Ansible, and Jenkins. These are again some kind of a workflows, but I think they understand more in terms of, or they are customized to the environment. Like I would give an example of Kubernetes. Argo CD is being used in Kubernetes platform across the multiple clouds. That means Azure, Google, even Red Hat, OpenShift, and the AWS uses Argo CD to a great extent for automating the deployments on the Kubernetes as a cluster, managing the microservices related environment, because that is being designed specially for those environments, and it has a capability to capture the drift. As I said earlier while I was explaining you the workflow, that important thing is to have to also monitor the drift. If something is not working, if some service is down, if some container is not running, if some node is not there, so that drift also needs to be captured and recorded somewhere before I can take action. Hence, these are the GitOps are the specialized tool for the deployment of infrastructure along with the configurations. So Flux CD also does similar thing. It is available both on Azure, AWS, you can use these tools to a fullest extent on any cloud, whether that is a public cloud, private cloud, or hybrid cloud. Again, something which was acquired by Red Hat was Ansible. Ansible as an also has its own templates. It does the automated provisioning configurations. So these are kind of the scripts. Now with the help of Ansible and Argo CD, the Red Hat OpenShift is actually built their own platform where they are doing their automation, and then you don't need to worry about if something is going wrong. I think automated action should take place so that service or the respective microservices are up and running along with the nodes. So these all things will be really helpful while you actually provisioning the environments. Okay, so from a GitOps tools per se, I think you need to concentrate on these as 4 as of now: Argo CD, Flux CD, Ansible. I think it started with the on-premise, but I think it is now pretty much everywhere around the public cloud providers also leveraging them. Similarly, Jenkins started with actually the cloud as the journey, but they now are even doing a lot of things on the from the platform per se, providing the Kubernetes automation along with the microservices which we just talked now. Okay, so these are the GitOps tools which you should remember. Now there is a very thin boundary between GitOps versus and configuration tools. Now ideally these GitOps tools are more specialized and widely used in the public forum. I would say a public cloud providers often use those terminologies, but from the what we started, like from the ages, I think we have been seeing the configuration management where we need to automate some kind of the platform services, whether they are the physical services, where even we're not having the virtual servers, they are all physical servers. So we were doing some kind of the configurations with the help of these tools which I have listed in configuration management. So now here also in configuration management tools, Terraform, Ansible are the multi-cloud hybrid which can provide all configuration management options for you on the cloud, public, as well as doing some like Terraform alone cannot work as the GitOps. You can work them along with the some clubbing them with some workflow engines, Argo CD, some templates, and then finally have them in pipeline. So ideally, what I'm trying to make sure is configuration management tools are more of providing right templates. GitOps will provide you a workflow design specially to do something on the platform automation, but that needs to be obviously work in conjunction. If you need to automate them in like example I've given you how the Ansible and the Argo CD is working together in case of Red Hat OpenShift. So those are the examples where you can mix match these tools to make the best of breed products being used for automation of your operations. Okay, so these are the again configuration management examples. Similarly, if you have been working on Azure, you know the Azure Manager, Azure Resource Manager templates, AWS Cloud Formation templates. Similarly, Google Cloud Deployment Manager. These are the actually the templates, like some kind of the they provide you the templates which can be deployed with their engines which are native to the cloud. Similarly, in case of other, which I have already talked about, Terraform, and they already have some kind of the control towers. Okay, so control towers are nothing but the control engine which makes a central repository kind of, and which takes a decision or controls your environment, maintains the configurations in the right shape and form. So there are different terminologies being used once we do the deep dives in the coming session, and we will take one by one. Like as I said, while we do the deployments, we will take one particular tool and do the deployments across the different public clouds, so that we are very much clear that really these tools which we have listed here, they work across the clouds and are suitable for your requirements or meeting your business requirements. Okay, so this is a configuration management. Last, which I have just started with, is the project management. Now this is also the from the project management per se, a very important and very useful, because this has been used to an extent where we are not just here to do the end-to-end build or end-to-end deployments. We need to have the actual incidents, actual request, or something present in system which can tell us if this is not working, this is an issue, this is a request to be deployed. So for that we need some kind of project management tool. Azure board provide us that feature where you actually create the sprint plan, your development plan, the feature, which resource are mapped along with their when they are working, how many hours they are working for a particular week. Those all things you can manage from a project management per se in these tools. So Azure board, it comes at the top because it is widely used across the GitHub as well as on day to day as well, because the other tools like even GitHub project does not have full functionality, the visuals, or even to that extent which Azure board provides. So this is the best tool you can leverage for a project management per se, which can actually creates the issues, even manages your respective sprints, who is working, resource planning, and all those things you can take care of. Similarly, Jira is also a very good tool from Atlassian, which does a similar kind of work, which we have seen Azure board and the GitHub project. And Confluence obviously is also the document management, which runs the from the retrospective, or I would say repetitive, like sprints planning, and how to do iterations across what is pending versus what is completed and all those things. So Confluence, Jira, GitHub project, and Azure board, these are the 4 tools I would suggest for the project management. Now what we have covered so far, I will just go up and just come down slowly. We have actually bucketed these tools in form of a source control management tools. Then we talked about the continuous integration tools. We also talked about the continuous delivery tools, GitOps tools, configuration management, and finally the project management. So idea behind this was to give you a overview of the automated operations and deep dive into the workflows. What exactly that DevOps, we all know, right? DevOps, we most of us know, but how many of us really know MLOps to that extent? How many of us really know DataOps, why that is meant for? Similarly, GitOps is very new to most of us who are starting fresh. Maybe I think it is an industry for more than now 4 to 5 years, but then still picking up a lot on GitOps. So this is in process, and as it is a master class, we are trying to cover everything in the depth. And in the next session, that is session 2, we will do the deep dive on one particular product across the multi-clouds. Okay, so with that, thanks for joining. We will meet up in the next session. Thanks. Take care. Bye.